Good morning, students. So in today's class, we are going to continue chapter 2, linear equation, pair of linear equations in two variables. So in the last class, we have seen how to frame the pair of linear equation for any situation which is given, right? So in today's class, we are going to see graphical method of solution of a pair of linear equation. In the last class, even we have seen how we can represent the data algebraically and graphically, right? So, in today's class, we are going to see how we can find a solution for a pair of linear equations. So far we have learned how to frame a pair of linear equation and how to represent it in algebraical method and also in graphical method. So now we are going to see how we can find the solution of a pair of linear equation. And I told you in the introduction class there are two ways of finding solution. One is graphical method and the another one is algebraic method. First, let us see how we can solve it graphical method. This sort of problems are very easy. We can proceed with the exercise with lighter introduction because we know already all these things. So first one, on comparing the ratios itself, we can see how the graphical representation and what the algebraic interpretation based on it. And if you remember all these things easily, we can conclude the problem, right? So we know what is A1, A2, B1, B2, C1, C2, right? When we talk about a pair of linear equations, then how you will express it in general form? First equation as a1x plus b1y plus c1 equals to 0, and the second equation will be a2x plus b2y plus c2 equal to 0. If these two are pair of linear equations, we know a1 and a2 are the coefficient of x, b1, b2 are coefficient of y, and c1, c2 are constant terms. Then compare the ratios. If a1 by a2 is not equal to b1 by b2, then it will be intersecting lines. If you express these two linear equations in graphs, we know how to express, right? We have done problems also. So if you draw graphs for these two linear equations, then it will be intersecting lines. Then what interpretation we can give about the solution of it? It will have exactly one solution. If a1 by a2 equal to b1 by b2 equal to c1 by c2, all the coefficients are equal, the ratios, see, the ratios are equal, which means it is not necessary it should have the same numbers. Even if you simplify it, after simplifying the values are equal also, it will be equal only, right? That's why it have given ratios. So if these are equal, then the graphical representation of these pair of linear equations will be coincident lines. You will get one line over the other. In such a case, we can say the pair of linear equations has infinitely many solutions. Then if a1 by a2 equal to b1 by b2, which is not equal to c1 by c2, the coefficients of the ratio of the coefficients of x and y are equal, but the constant is not equal, then we know the graphical representation will be parallel lines, and in such a case it won't have any solution, right? And when it has exactly one solution and infinitely many solution, we will say the system of equations are consistent. When it has no solution, we will say the system of equations are inconsistent. And moreover, when it is infinitely many solution, we will say the equations are dependent. It is depending one over the other. So based on all these things, you may get questions. They may give a pair of straight lines and they may ask how the graphical representation of these lines are going to be. Check which two lines have intersecting lines, which has coincident lines. So without representing the lines on a graph, you can easily conclude based on comparing the ratios. Comparing the ratios itself, you can conclude definitely this pair of linear equations will have intersecting lines, this will have coincident lines, this will have parallel lines. Like that you can conclude without representing graphically. And similarly, you can get questions like this, which they may give a pair of linear equations and they ask which pair of which system of linear equations are consistent and which system are inconsistent. Again, on comparing this, if it satisfies these two conditions, we can say the systems are consistent. If it satisfies this, we can say the system is inconsistent. Similarly, based on the solution, which has a unique solution, which has infinitely many solutions, which doesn't have any solution, all these kinds of questions can be asked on giving a pair of linear equation. So without solving it, without representing it graphically or algebraically, we can very well give a solution based on these, but we cannot give the exact solution. If we want to give the exact, we can state it has exactly one solution, but what is the solution? To find that, we have to express it graphically or we have to solve it algebraically, right? Or a general interpretation we can give on comparing these ratios, right? Now let us directly move on to the exercise. No more explanation is needed to solve these exercises, right? But you have to remember this table and the ratios. If coefficients of x and y are not equal, it is intersecting lines. If all the ratios are equal, coincident lines. If a and b are equal but c is not equal, parallel lines. Okay. Now let us see how we can solve the problems. The first question is, form the pair of linear equations and solve. So read the question properly and then answer. If they ask you to solve only, you have to solve. If they ask you to form only the linear equation, it is enough if you frame the linear equation and if you stop the problem. And again, solve graphically or algebraically, that also will be mentioned in the question. If they mention, you have to go with that method only. If they don't mention and if they simply give form the pair of linear equation and solve, you can choose your own method, either a graphical method or algebraical method. In this question, they asked you to solve graphically, so you have to go with graphical method only. Now the first question, 10 students of class 10 took part in a mathematics quiz. If the number of girls is 4 more than the number of boys, find the number of boys and girls who took part in the quiz. So now what we are going to do is, and you know, whatever question is asked, that only should be your assumption. Here they asked you to find the number of boys and girls. So take your assumption from there only. So let the number of girls be x and number of boys be y. Why girls should be x and boys should be y, you can take in any way, no matter. You can take number of girls as y and number of boys as x. Okay. Here I have taken girls as x and boys as y. And it is given total number of students in the class is 10. So x plus y is equals to 10. This will give our first equation. Next they have given you number of girls is. So number of girls we have taken it as x. Is means immediately you have to put equal to 4. More than means plus. 4 more than means plus. Number of boys is y. So number of girls is equal to 4 more than means plus. Number of boys we denoted by y. So x is equals to 4 plus y is your second equation. If you want, you can express it in a standard form by bringing y to the other side. So x minus y equal to 4. Thus we got two linear equations. Now with these two linear equations, by comparing the ratios of the coefficients, we can check what type of solution it will have. Now what is a1 here? 1. a2 1. So a1 by a2 is 1 by 1, right? So compare a1 by a1. So 1 by 1, right? Then b1 is 1. b2 is minus 1. So a1 by a2 is not equal to b1 by b2, right? If a1 by a2 is not equal to b1 by b2, then how the graphical representation will be? Intersecting lines. And how many solution it will have? Exactly one solution. This is just for your verification. So if you represent these solutions graphically, you should get intersecting lines and exactly it will have one solution, right? Now you know how to draw graphically, how to express the pair of linear equations graphically. Take your own values for any one of the variable, find the corresponding values of the other variable. We have done problems of this kind in the previous exercise also. So after getting the values of one equation, plot it in the graph and then move on to the second equation. First, initially you can tabulate the values, then plot it for one graph, draw the line, and then plot it for the second equation and draw the line. If you plot all the points, then you don't know which point belongs to which line. After plotting it, draw the lines and see where it intersects. With the values which you have chosen, it may not intersect. So don't conclude the lines are not intersecting. You have to extend your line and see where it intersects. Definitely it will intersect at one point, and this point is a solution of the pair of linear equations. Since I have not done in a proper graph sheet, I may not get a correct solution. Do it in a graph sheet or take proper scale and do it, so that you can find the solution of the pair of linear equations. How will you find the coordinates of this intersecting point? Where it intersects at x-axis and where it intersects as y-axis will be the solution. So here it intersects the x-axis at 7 and at y-axis it intersects at in between 2 and 4, therefore it should be 3. Therefore the solution is 7, 3. Solution is 7, 3. 7 denotes x value and 3 denotes y value. This is your x value and this is your y value, right? So x, we denoted x by number of girls, therefore number of girls is equals to 7 and number of boys is equals to 3. Thus we got total number of students as 10. This how only you have to solve pair of linear equations using graphically. After drawing it in a graph, you have to extend the lines and see where it intersects. That intersecting point will be the solution, right? Hope you understood. Now second question, I am going to leave it to you. See, 5 pencils and 7 pens together cost rupees 50, whereas 7 pencils and 5 pens together cost rupees 46. Find the cost of one pencil and that of one pen. I told you take your assumption from the question. They asked you to find the cost of one pencil and one pen. So assume, let the cost of one pencil be x and the cost of one pen be y, right? So how will you frame your equation here? 5 pencils, so 5x plus 7 pens, 7y equal to 50 will be your first equation. Then 7 pencils and 5 pens, so 7x plus 5y equals to 46. To confuse you, they may change the order also. So compare your assumption, check the question twice and then make your equation. So after getting two equations, again you can represent it graphically and you can find the solution. Here also you can compare the coefficients or the ratios and you can check before getting into the problem what sort of problem it is, whether it will have intersecting lines or parallel lines or coincident lines. Then you can find your solution. So I am leaving this problem to you. You have to do this as homework. Now we are moving on to the second problem. On comparing the ratios, find out whether the lines representing the following pairs of linear equations intersect at a point or parallel or coincident. So they didn't ask you to represent a graph and all. They have given you three systems of pair of linear equations. They just asked you to compare the coefficients and check, right? So let us see how we can do this. See the second question. Now we have listed out the two equations. Now write what is a1, a2. a1 is coefficient of x, so 5. Here it is 7 and b1 is minus 4. Along with the sign only you have to write. b2 is 6, c1 is 8, c2 is minus 9. And find what is a1 by a2, b1 by b2 and c1 by c2. If you can simplify it, simplify and then compare the ratios. With the actual values, it is not necessary you have to compare, because sometimes with the actual values it may not be equal, but after simplifying it may be equal. That's why it is given as the ratio. So simplify and then compare. Now if we see minus 4 and 6, we can simplify it as minus 2 by 3. So 5 by 7 is not equal to minus 2 by 3. So A1 by A2 is not equal to B1 by B2. So when you see the necessary conditions, A1 by A2 is not equal to B1 by B2, then it should be intersecting lines. When it is not equal, you don't want to check for C1 by C2. If it is equal, then you check whether C1 by C2 is equal or not equal. If it is equal, it will be coincident lines. If it is not equal, it will become parallel lines. When A1 by A2 is not equal to B1 by B2, then you can stop there itself. You don't want to check for the ratio of C1 by C2, because with this only we can conclude that the two pairs of linear equations are intersecting lines only, right? If they are not equal, you stop with that. You don't want to check with C1 by C2. If they are equal, check for C1 by C2. If C1 by C2 is also equal, it will become coincident. If they are not equal, it will become parallel lines, right? So here if you see A1 by A2 is not equal to B1 by B2. Therefore, the graphical representation will be intersecting lines and they will intersect at one point. So you have to write therefore A1 by A2 is not equal to B1 by B2. So which implies they are intersecting lines and they intersect at one point. Intersect at one point. This is how you need to conclude your answer, right? Similarly, you can solve the remaining two problems by finding the ratios and comparing. Only if A1 by A2 equal to B1 by B2, you check for C1 by C2, and before checking, after writing like this, simplify if you can. After simplification, you go for the checking of the ratios, right? Now we will move on to the third question. So as I told you, three types of questions can be asked on comparing the ratios. One is to check the graphical representation of the system, whether it is intersecting, parallel or coincident, as we saw in the second problem. The next one is to check the consistency of the system, whether the system will be consistent or inconsistent. The third one is based on the algebraic interpretation. What will be the solution of the pair of linear equation, whether it will be a unique solution or infinitely many solution, or it does not have any solution. So three types of questions can be asked based on comparing the ratios. So second problem based on the graphical representation or geometrical representation of the system of equations. Now the question is to check whether the system is consistent or inconsistent. When it will be consistent? In two cases it will be consistent. When the geometrical representation is intersecting lines and coincident lines, the system will be consistent. If they are parallel lines, then the system is inconsistent. Again, this can be checked by comparing the ratios, right? We will do one problem and see what type of system of linear equations they are. Here I have solved the third question. See, the question is 3 by 2x plus 5 by 3y equal to 7, 9x minus 10y equal to 14. The same way, list out what is a1, a2, b1, b2, c1, c2. So here 3 by 2, here it is 9, here it is 5 by 3, here it is minus 10, c1 is 7, C2 is 14. Remember, the general form of expressing is A1 by A1x plus B1 now y plus C1 equal to 0. So here both the equations, the constant term is after equal to sign. In such a case, it won't create any issues. Suppose in one equation constant term is left side of the equation, and one equation the constant term is on the right side of the equation, make it same sort of representation and then take out the values. Because the sign differs, you will get a wrong answer. Hope you understood. In the first equation also equal to 7, the second equation also equal to 14. Suppose if it is minus 7 equal to 0 in the first equation and it is equal to 14, then change any one of the equation to the same format and then take the values and proceed with your problem. right? So here after listing out the a1, b1, c1, c2 values, find the ratios. Now a1 by a2 is 3 by 2 by 9. Hope you know to solve this. So 9 will come to the denominator, right? So as I told you, simplify the values and then compare the ratios. Don't directly compare the ratios. So 3 3s are 9, so you'll get 1 by 6. b1 by b2, if you solve it, you are getting minus 1 by 6. And remember, again and again I am repeating, when you are taking the coefficients, take the values along with the sign. Even the sign matters a lot. And then c1 by c2 we got 1 by 2. And first compare the ratio of a1 by a2 with b1 by b2. Here it is 1 by 6, here it is minus 1 by 6. As I told you, even if it differs from sign, they are not equal only. So a1 by a2 is not equal to b1 by b2. When it is not equal, you don't want to move further for the comparison of c1 by c2. Only if it is equal, you have to check whether c1 by c2 is equal or not equal, because accordingly the interpretation will change. Here a1 by a2 is not equal to b1 by b2. So clearly they are intersecting lines and they are intersect at only one point, and hence the system of or the pair of linear equations is consistent. Here the question is not about the solution, about the consistency of the system. So appropriate answers and appropriate conclusion you should give. After comparing, if they ask about the algebraic interpretation, how many solutions it will have, you should not write the system is consistent. You can write, but whether it has a solution or not, that point you have to mention. Right? Here they asked about the consistency, so you have to give whether the system is consistent or inconsistent. Right? Hope you understood. We will move on to the next problem now. Fourth question, if you see, which of the following pairs of linear equations are consistent or inconsistent? If consistent, obtain the solution graphically. First they asked you to check whether it is consistent or inconsistent, and then they asked you to obtain the solution graphically. So we have to solve it. We should not stop by saying whether it is consistent or inconsistent. Right? If you see the first problem, see a1, a2, b1, b2, c1, c2 I have listed out and I have found the ratios, and after simplifying it I found it a1 by a2 is same as b1 by b2. When it is equal only, I am moving on to the third ratio and checking that is also equal. So when all the three ratios are equal, then immediately what sort of geometrical interpretation we will get, representation? It will be the coincident lines with infinitely many solutions. And here your question is checking out the consistency of the pair of linear equations. So for that you should give the answer. Hence the system is consistent. Hence the pair of linear equations is consistent. You have to write that. After giving the solution for the first question, whether it is consistent or inconsistent, you have to move on to the graphical representation to find the solution, because they asked you to find the solution. If it is unique solution, you can write this is what the solution. If it is infinite, see this problem you will get a overlapping lines, one line over the other. Then how will you write the answer? It will have infinitely many solutions. You can give the answer like, from the graph we can see it has infinitely many solutions. So every point on the line is a solution of the problem. Let me list out few. So you can list out few points, right? Or else you can write it as infinitely many solutions. After saying infinitely many solutions, don't write only one point as your answer. Clear? So after this, what you have to do for this problem? After this, draw the graph of two lines and express it graphically and find a solution. You have to write the solution of this problem, because they asked you to solve this problem graphically. You should not stop with this, right? I am not doing it, you have to do it. You have to solve it graphically. See the fifth question. Half the perimeter of a rectangular garden whose length is 4 meter more than its width is 36 meter. Find the dimensions of the garden. When you have statement problems like this, read it twice, thrice, understand it, and then frame your equation. Here we are dealing with pair of linear equations. So with the given data we have to frame two equations. So half the perimeter of a rectangular garden. So first, what is perimeter of a rectangular garden? And before getting into this, first we should make our assumption. Find the dimensions of the garden. So your assumption should be dimensions of the garden, and it is clearly seen rectangle. So your dimensions will be length and breadth. So let the length of the garden be x and breadth be y, right? Length we have taken it as x and breadth as y. Now our first statement, half the perimeter. So what is perimeter of a rectangle formula? Twice L plus B. So twice L plus B. L we have taken it as x, B we have taken it as y. This is perimeter, but they have given half the perimeter. So half the perimeter of a rectangular garden. Leave the statement in between. Half the perimeter of a rectangular garden is 36 meter. This means equal to 36. When you have comma there is a pass with the sentence, right? So half the perimeter of a rectangular garden, comma. Again here you have a comma. So there is a break in between, is 36 meter. So half the perimeter is 36. So 2 and 2 will get cancelled. So x plus y equals to 36 is your first equation, right? Now read the second statement. Whose length is, length we have taken it as x. So x is equals to 4 meter, 4 more than, so plus its width with this y, or else x minus y equals to 4 is your second equation. Yes, hope you understood. Translate it word by word so that you will get a correct equation. Whenever you have is, you have to put equal to. Whenever you have more than, plus, less than, minus. So word by word you translate, you will get a proper equation. Now we got the two equations. Then asked you to find the dimensions of the garden. So how you will do it? You have to solve the pair of linear equations. So far we have learned only graphical method. So solve these set of pair of linear equations graphically and then find the solution. And if it intersects, see obviously a1 by a2 is not equal to b1 by b2, therefore it will be the intersecting line intersecting at only one point. That point will be the solution, and that x value will give you the length, that y value will give you the breadth, because they asked you to the dimension. After plotting it in the graph, you should not stop with that, because the question is to find the dimension. So at last you have to write, therefore the length is this much and the breadth is this much. You have to write the answer, right? Hope you can do this. Now let us see the sixth problem. Given the linear equation, write another linear equation in two variables such as the geometrical representation of the pair so formed is intersecting lines, parallel lines, coincident lines. This is very easy. They have given you one equation. They asked you to write another equation in such a way both the equations should be intersecting lines, parallel lines, coincident lines. You know the condition for these three things to hold good. What are the conditions? For intersecting lines, a1 by a2 should not be equal to b1 by b2. So accordingly give your own coefficients for x, y and constant term. You can very well get your, giving your own example is not that much difficult, right? You can give whatever number you want in such a way a1 by a2 should not be equal to b1 by b2. When you come to parallel lines, all the three should be same, so that you can give the multiple of this. Multiple of the same multiple. For example, if you are going to take 2, you can give 2 2s are 4. So 4x plus then 3 2s are 6y minus 8 2s are 16. So in that same sign also you should give. Then only you will get the same values. So you find the ratio, you will get 1 by 2, 1 by 2, 1 by 2. Therefore it will be coincident lines. For parallel lines, give the same multiples of this a1 and b1. And don't give the same multiple for C1. In such a case, you will get the parallel line, because parallel line A1 by A1, A2 should be equal to B1 by B2, but it should not be equal to C1 by C2, right? We have the table. Looking at the table, accordingly you give your own values. Now move on to the last problem. Draw the graphs of the equations. Determine the coordinates of the vertices of the triangle formed by these lines and the x-axis. Shade the triangular region. So they told you draw the graph. After drawing the graph, and obviously it will intersect at one point, they have told you you will get a triangular region with the x-axis and shade the triangular region. This is again a easy problem. So with this we have completed exercise 3.2. It's a very easy exercise where nothing new in this. All the problems are of same method. So you can learn it very easily, and it's a mark scoring chapter even. So keep on practicing. Do these problems as homework and post it in the group before evening, and if you have any doubts, contact me. Thank you, students.